Alright, let's take a look at question 15. And question 15 in this problem, you're assessed on how to transform quadratics by completing the square or by expansion. Okay? Alright. The question reads, which equation has the same solutions as x squared plus 8x minus 33 equals 0? So there are two methods we're going to use for this problem. The first method involves going from the expanded form into the factored form. And then the other method will involve going from the uh, factored form into the expanded form. The difference is the first method we are going to be going from the question to the answer. Alright, so that's method 1. Let's go ahead and write that down. Method 1. Method 1 is your completing the square method. It's called completing the square. Okay, for completing the square, you're going from the question to the answer. The question is x squared plus 8x minus 33 equals 0. So first things first, we want to create an incomplete square on the left side. So in order to accomplish this 33 needs to go to the right side. So we move the constant over. We're trying to create a perfect square trinomial. Okay, so we have x squared plus 8x, and we need a term here to make this a perfect square trinomial. But whatever term we insert in this spot to make the left side a perfect square trinomial, we have to add exactly the same thing to the right side. So what are we going to use to complete this square, to make this a perfect square trinomial? Well, what you have to do is you want to add b over 2 square. So that's how you complete the square. You add b over 2 square to both sides. Okay, let's do it. So we're going to have x squared plus 8x plus b over 2 square. And then we added that to the left side, so we're going to do the same to the right side. 33 plus b over 2 square. Okay, so what on earth is b over 2? Now if you look at this equation right here, the coefficient of the x squared is a, that's a, and the coefficient of x is b. Okay, so let's figure out what b over 2 square is on the side here. B is 8. So when you divide it by 2, that's going to give us 4. So b over 2 square is 4 square, which is 16. So that's what completes the square. On the left side, we have x squared plus 8x plus 16. This is a perfect square trinomial. And on the right side, 33 plus that 16. That resulted from completing the square on the left side. Now to factor the left side, since it's a perfect square trinomial, we're going to use a factorization shortcut. We factor the first term and the last term and bring down the middle sign. Okay, so the factored form is going to be x plus square root of 16 is 4, quantity square. Okay, and on the right side, 33 plus 16 is 49. So the answer to question 15 is option number 1. Alright, so this is a factor method. Completing the square method, which is a little bit involved. You need to know what the algorithm is. You need to know your steps and the factorization techniques needed here in order to do it. Now let's assume that you do not know how to complete the square. Well, you resort to method 2, which is pretty familiar to most. Method 2 is your expansion method. Okay, so for method 2, we're going to expand. And what we're doing is we're going from question answer to question. The penalty here is that we have to keep expanding until we get to the correct answer. So we are doing it blindly. We don't know what the correct answer is. Alright, but in completing the square, we're going, it's a direct shot. We're going from the question, and if we do it correctly, we just hit the answer. But when we're doing the reverse, we're just expanding these to see which one results in this when placed in standard form. Okay, so let's start with option 1. What do you think will happen with this one right here? X plus 4 squared Do you think if we expand it completely and put it in the standard form that it will be the same as this? Well, it should be because that's what we got using method 1, right? If not, there is going to be a problem. Alright, so we'll start by getting rid of this parenthesis. Notice the standard form has no parenthesis in it, so we will multiply x plus 4 by itself, and that equals 49. So you're multiplying two binomials, so you can just FOIL it out. First, outer, inner, and then last. Double distribution. Bam. Now when you multiply, you're going to have x times x is x squared. That's first. Outer x times 4x is plus 4x. Outer, inner, 4 times x is 4x. Last, 4 times 4 is 16 equals 49. Now let's combine like terms. Positive 4x and positive 4x are your first degree terms, so we combine those. And then we have x squared plus 8x plus 16 equals 49. Our target expression has a 0 on the right side, so to make this 0, we have to subtract 49 from both sides of the equation, and that will give us our desired result. If we carry out the subtraction, we are going to get x squared plus 8x, and then if you do that with your calculator, you get minus 33 equals 0, and this is a match, so the answer is option number 1. Now, had it been that we got something that doesn't match the original quadratic equation, then that will mean that either that's the wrong answer or we did it incorrectly. Hopefully the first is the case, that it's not the answer, and then we just move on to the next one and expand. So when you expand all of them, you will definitely end up with 1 if you did it correctly, and the one that matches the question is the correct answer. Alright, so this is how you transform quadratic equations from expanded form into factored form. Thanks so much for taking the time to watch this presentation. Let us know what you think. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions, comments, or special requests, feel free to post it in the comment section below. Don't forget to subscribe to our channel for updates to the remainder of this review series. More support resources can be found at mathgotserved.com under the New York Regents page. Thanks again for watching and have a wonderful day. Goodbye.